To convert the parametric equations into the Cartesian equation, one way is to make t the subject in terms of x and then you sub into the y function, but you will see that this method does not work for this question. For example, if you start off with x equals to 2 secant t, which is 2 over cosine t, and therefore cosine t is 2 over x, t is cosine inverse 2 over x, and then you sub into the y function, you're going to get y equals to 3 tangent cosine inverse 2 over x. Now, this equation here, if you use your GC in the function mode to graph it, you will actually get part of the curve C that we have in this particular question. Okay, what you can do is you can check this against the graph that you sketch using the parametric mode. Okay, you will see that you will only get part of the curve, and the question I have for you is, why is this the case? So now let us look at the correct way to answer this question. Notice that there is a secant and tangent in the parametric equation, okay, meaning that I can relate this to the trigo identity 1 plus tangent square is secant square. Okay, so to get the Cartesian equation, I have to express everything in terms of y and x. So from the parametric equation, your tangent t is actually y over 3, so square, and your secant t is x over 2 is square. Okay, so now what I have is basically a Cartesian equation, okay, for y and x. Okay, so from here, what I can do is simplify this into the standard form. I'm going to get x squared over 4 minus y squared over 9 equals to 1. And this allows us to see that this curve here is basically a hyperbola. Part 2 of the question wants us to sketch the curve C, stating the equations of the asymptotes and the coordinates of the points where C crosses the axis. So identify this as your hyperbola. Even if you're not sure, given the Cartesian equation, right, either using the Cartesian the function mode or the parametric mode in the GC, you should be able to get a graph of this shape, and that will indicate that this is a hyperbola. So what you need to do now is to add in the two oblique asymptotes and label the equations of the asymptotes as well as the points where the C crosses the axis. And how do we get the equations of the asymptotes? Okay, remember that the equations of asymptotes is given by y equals to plus minus b over ax, okay, for a hyperbola centered at the origin. So what's the a and the b? From the equation itself, the value 4 here, which corresponds to x squared, is basically your a squared, and the value 9 here that corresponds to the y square is basically the b square. So in other words, the two oblique asymptotes is actually y equals to plus minus 3 over 2x. Right? Now let us give a proper sketch of this hyperbola. Okay, with the x and y axis labeled, notice that this is the sketch of the hyperbola with the equation x squared over 4 minus y squared over 9 equals to 1. Okay, what are the things to take note of when sketching this curve? First, you're asked to state the equations of the asymptotes. So make sure that you have the equations of the two oblique asymptotes stated clearly on the diagram itself, as well as the coordinates of the points where C crosses the axis. Now be careful of the use of the word coordinates. If the question asks for coordinates, the point where it crosses the x-axis must be given as a coordinate point xy. Alright, so you shouldn't be writing it as an x-intercept. So if you write as x equals to minus 2 without giving the coordinate form, this will be marked wrong. One other important point to take note of when drawing graphs with asymptotes basically is the asymptotic behavior of the curve. So in this case here, you have to sketch the curve such that the graph or curve actually approaches the asymptotes when x tends to plus minus infinity. So the asymptotic behavior must be shown clearly on the diagram. So you shouldn't be drawing graphs where the curve actually is parallel to the asymptote, touches the asymptotes, or crosses the asymptotes. Okay, so the asymptotic behavior must be shown clearly on the sketch. You should also note that this curve is actually symmetric about the x-axis as well as the y-axis. So your sketch should actually show this symmetrical property and should not be out of shape. In other words, you shouldn't be drawing something like this. This would be a bad drawing. Okay, for example, like this. Okay, where somehow this part here is gone, shorter than the other part of the curve. Okay, when it is viewed as a symmetry about the y-axis. So the symmetrical property of this curve must be clearly sketched on the diagram itself. Okay, another point to take note of in your sketch is please draw a sketch as big as possible. It is actually good for you to draw a bigger sketch so that all these properties are clearly exhibited or shown on the diagram itself. What I meant is this, a good habit is use at least half page of your A4 size paper, okay, to draw a sketch. So you put in the x and the y-axis. Now treat the x and y-axis as the boundary of your graph. So in this case, a good way to sketch the hyperbola for this question is draw the graph as big as the boundary formed by the x and the y-axis. Okay, so in this case, what I have would be, I can give a sketch of something like this. Okay, as you can see, this is bad drawing. Okay, it shouldn't be parallel to the asymptotes. Okay, so for those who can't actually draw a nice curve with the asymptotic behavior, I'll propose that you keep practicing this. Okay, keep drawing to perfect your skills. Okay, so that is what I meant by drawing a graph as big as the boundary created by the x and y axis. Okay. Some drawing will be stuff like this. This is your labeled x and y axis, but your graph looks like this. Okay, or the other way around. This is your x and y axis, but your graph actually extends beyond the x and y axis that we have drawn. Right? So these two are actually bad examples of curve sketching, okay, on a single diagram. Right? Moving on to part 3. We are told that the line y equals to square root 3x plus k, where k is negative, is a tangent to the curve C. And what we are required to do is to show that k has a value of negative square root 3. So I'm going to show you two methods of answering this question. The first method is making use of the fact that we know that the gradient of the tangent is square root 3. So we start off with finding the gradient of the tangent to the curve C, which is given by dy dx. And since we have the set of parametric equations given to us, we can work out dy dx by taking the product of dy dt and dt dx. Okay, by differentiating y and x with respective to t and then using the chain rule, you should be able to obtain dy dx to be 1.5 cosecant t. Given the fact that the gradient is square root of 3, we just need to equate these two and find out what is the value of t. Now, majority of the students, we were able to obtain t equals to 1/3 pi, but forgot that t can also take the value of 2 pi over 3. Since in the question, we were told that t is a value between negative pi and pi, and 2 pi over 3 actually falls within this interval. So this is an acceptable value of t that we should also take into consideration. So when t equals to pi over 3, plug into the x function, you get a value of x equals to 4, and plug into the y function, you get a value of y equals to 3 root 3. So the x, y values, as well as the gradient at the particular point known, we can use this to formulate the equation of a tangent, which is basically the equation of a straight line. So using the fact that the equation of a straight line takes the form y minus y1 equals to m times of x minus x1, where m is the gradient and x1 and y1 is just the coordinates of a point on the curve. Okay, so you sub in the gradient as well as the x and y values. Okay, and then just do some manipulation to this equation. We should be able to show that the equation of this tangent is y equals to root 3 x minus root 3, and hence your k value is negative root 3, which is what we are required to show. But don't forget that we also have to consider the other value when t equals to 2 pi over 3 to show if this is also an acceptable value. So what value of k do we get when t equals to 2 pi over 3? So here it is. So when t equals to 2 pi over 3, you have the x value to be negative 4 and the y value to be negative 3 and root 3. Likewise, sub this into the equation of the line. So this is the x and y values as well as the gradient. Simplify this equation, you will get the equation of this line to be y equals to root 3x plus root 3, and hence giving us k equals to root 3, which we have to reject because in the question we are told that k is actually negative. So a question to you will be, what does this tangent represent for the curve? One important point to take note of here for this particular question is when solving a trigo equation, okay, what are the possible values of the roots of the equation you can get, okay, given the interval that is being considered. Now let us look at another method to answer this question. Method 2 uses the idea of discriminant to help us answer the question. So in this question, we know that the equation y equals to root 3x plus k is a tangent to the curve C. Alright, so this line or this tangent here actually meets the curve C at one point for this particular graph. So what we can do is we try to find the intersection of the tangent and the curve C by substituting the equation of the tangent root 3x plus k into the equation of the curve C, which is the hyperbola. Right, so from here what we can do is again do some manipulation of the equation to form a quadratic equation in x. So noting the fact that the tangent to C meets the curve at this particular point, right? The discriminant b squared minus 4ac is actually equals to 0. Alright, since it is a repeated root, your b squared minus 4ac is actually equals to 0. And then what you can do now is just put in the values of a, b, and c right, from this quadratic equation that we have here into the discriminant formula. And from here, we gather that your k squared is equal to 3, and therefore your k has two values, positive and negative square root of 3, and of course we reject the one that is positive, since we're given that k is a negative value, right? Now, noting the fact that this is a show question, all the steps must be given in your solution, no matter how trivial it is. Okay, for any show solution, details must be given. Okay, you cannot leave out any detail and jump straight away to the final given answer. For the last part of this question, we are asked to find the volume of a bounded region being rotated completely about the x-axis. Right? So what we have to do first is to identify this region correctly. So from the diagram itself, we note that this region is bounded by the tangent line, y equals to root 3 x minus root 3, as well as the curve C and the x-axis. So this is the region that we are interested in. Okay, and we want to rotate this region about the x-axis. Since this region is bounded by two different curves, what we need to do is we need to do some form of subtraction. But before doing that, we need to know what is actually this point of intersection, right? So if you have done some workings in the earlier part of this question, you will realize that the x coordinate of this point of intersection has a value of 4. Okay, so this is the value of x, okay, at the point where the line y equals to root 3 x minus root 3 is actually tangent to the curve C. So after knowing all the points of intersection and where the curve and the tangent line crosses the x-axis, we are ready to find the volume of the red shaded region being rotated about the x-axis. So what we can do here is, first we consider this triangle. So when you rotate this triangle about the x-axis, you actually get a cone. So the volume of this cone is given by the formula 1/3 pi r square h. Okay, without doing any integration, we can just put the formula for the volume of the cone. And then what we need to do now is to subtract the volume obtained by rotating this green shaded region bounded by the curve from x equals to 2 to x equals to 4 about the x-axis, right? So when you rotate this, since this is not going to give us some known solids which we can apply a certain formula, that is when the integration part comes in, right? So applying the integration formula for the volume of a region bounded by the curve rotated about the x-axis, what we are going to get is actually pi integral y square dx. Okay, and then of course your x runs from 2 to 4. Okay. And what we need to do now is to take the volume of the cone and then you subtract the volume obtained by rotating the green shaded region about the x-axis. Okay, so now what we need to do is put in all the values for the unknowns. So for the cone itself, what is the radius r? So if you look at this diagram itself, the radius r is given by 3 root 3. So we can plug it in, you get 3 root 3 squared. And what is the height of the cone? So the height of the cone in this case here is basically 3 units. So this height is 3 units. Okay, then next come to the integral we have here, the definite integral. So what is the y? So here the y represents the equation of the curve C. And what we can do is we make use of our answer in part 1, where we actually have already obtained the Cartesian equation of C. So from part 1, what we have is x squared over 4 minus y squared over 9 equals to 1. So do some form of rearrangement. Your y squared is actually 9 times of x squared over 4 minus 1. Okay, and this is quite nice because this is already in the form y squared, and then you can plug this into the definite integral formula. Okay, and then we are done. So in this question, some keywords to take note of. You are asked to calculate the volume. So when you see this word calculate, usually it refers to the allowance of using a GC to obtain the value, and then you round off to 3SF. Alright, instead of actually performing your integration techniques to try to find the value of this definite integral. Okay, and in this question, it doesn't say that you have to find the exact volume, so we can still use the GC. Right? So using the GC, just perform a simple calculation. You should be able to obtain the correct value. So in this case, if you do a correct calculation, you will get a value of 9.42, and this is to 3SF, and that will be the volume obtained.